We begin our chapter on alkenes and cycloalkenes. First off, we're going to start with alkenes. So an alkene is an alkane, except it has a double bond, right? It has a double bond. So normally if you were to ignore this double bond, right? Let's say we had this. We had 1, 2, 3, 4. This would be a butane, right? A butane. But when we add the double bond, we're actually going to get butene, right? And notice that the ane just changed to an ene because this is what? An alkene. So when you're numbering, you want to pick the number of which the double bond starts at, right? So this is going to occur at carbon 1 and carbon 2. We will say that this right here is a 1 butene. Now let's do another one. Let's do 1, 2, 3, 4, 5, and 6. That's a hexane, but when we add a double bond, it becomes a hexene. Right? Hexene. And this occurs at 2 and 3, so we will say this is a 2 hexene. Right? Alright, so let's say that you have a substituent, right? So this has 1, 2, 3, 4 carbons, so that would be a butyl. However, this has a double bond, so it's going to be a butene. And this is a methyl group, and it is attached to the number to the second carbon. So it's a 2 methyl. So we're going to bring this all together. We have a 2 methyl dash, and then you have to say where the double bond is located. In this case, the double bond is going to be on the second carbon. It's going to be on the second carbon. So you say 2 dash butene. So if I were to give you this this name and told you to write out the structure, you would know that this has 4 carbons because it's a butene, and because of this number 2 right there, you would know that you have to place a double bond on the second carbon, and on that second carbon is a methyl group as well. Okay, so let's do another one really quickly. Let's do one. Oh wait, before I do that, here's another way to actually name it. So you remember how when we were doing alcohols, we could shift this number 2 right over there, right? So we can do that here. We can do 2 methyl but dash 2 dash ene. So that could be an answer choice, or it could be a structure that they want you to write out. So how would you name this molecule? Well, normally you just want to count out your carbons first. So 1, 2, 3, 4, 5, and 6. That would be the longest chain possible. Okay. Now we count out our substituents, our children. There is a... Well, first of all, do I want to number it from 1, 2, and 3, going from right to left? Well, no, I don't, actually. I want to number it so that the double bond is closer. See, if we have a basic alkene group, basic meaning that there's just methyls or no chlorines or halides or whatever, just simple carbons and hydrogens. Well, I'm going to consider the double bond to be more important than a single bond, right? So I'm going to say that 1, 2, and 3 would be correct going from left to right because double bonds are more important than simple alkanes. So we will say that this is a methyl group on the second carbon. 4 and 5, we will say that this is a methyl group on the fifth carbon. Right? And that's 6, so this is going to be hexene. It would be hexane, but a double bond makes the ane change to an ene, right? So let's put this together. 2, 5, dash, di, methyl. Now where's our Where's our double bond? Is it on the 4th carbon? Is it on the 5th carbon? No, it's on the 2nd and 3rd carbon. So we're going to say 2-hexene. Another way you can write it out is 2,5-dimethyl hex-2-ene. Right? So you could just put this 2 right here between the hex and the ene, and it'll be perfectly correct. Okay, so we're going to start. Whenever you see like these methyl groups right here, they're not as important as the double bond, so instinctively you should be numbering your molecule from left to right, closest to the double bond. So 1, 2, 3, 4, 5, 6. There's 2 methyl groups on the 5th carbon, so we will say 5,5-dimethyl. And I mean, we're halfway there. Might as well write out the full name. My double bond is occurring from the 2nd and 3rd carbon. Well, we're going to say it's on the 2nd carbon, so 2 dash. Now this is a hexene, so it is hex-ene. Another way you can write it is 5,5-dimethyl hex-2-ene. Just kind of like bring that 2 right there between the hex and the ene. For this question, it's kind of hard to number it, right? So we have a butane that's 1, 2, 3, 4 carbons. But if I number it right here, if I number it going left to right, 1, 2, 3, and 4, then we have a chlorine on the 4th carbon. Well, I'd rather have chlorine being on the what? On the 1st carbon, and then my double bond on the 2nd, right? It's better than having a double bond on the 3rd and a chlorine on the 4th. So 1 and 2 add up to 3, and 4 and 3 add up to 7. So 3 is going to be less than 7, and thus more favorable in my case. So we will number it from right to left. 1, 2, and 3, 4, right? So we have a 1 chloro. Where's my double bond? It's on the 2nd carbon. And that is not a butane, but a butene. We can also number it as follows. 1 chloro, but-2-ene. And here are some common names that you might see in organic chemistry. This is a 1, 2, meaning that is a ethene, because 2 carbons means ethane, but since it's a double bond, it's going to be ethene. So it is ethene. Two carbons double bonded together, that's an ethene. Right here, we have 1, 2, 3, so you're expecting propane, but instead we have propene. On the other one, we have 1, 2, and 3, so you're expecting propane. And there's a methyl group on the 2nd carbon. So that is a 2-methyl propene. Or if you can realize that this is kind of like a Y shape, that's a Y shape, you can say that this is a isobutyl and then butylene. So isobutylene, because the ene signifies that this is a double bond. The isobutyl is a what? It is a 1, 2, 3, 4. So if that's 4, then actually, yes, it's still called propene. So it's not that good. I don't really agree with this. It's not intuitive. You're expecting like 3, 1, 2, 3, and 4, but actually it's 4. So it doesn't make any sense, to be honest. I prefer to go with isobutylene. Butyl is 4. That makes more sense. But I mean, that's nomenclature. These are the common names. So if you see that on an exam, just commit that to memory, and you'll be fine. Now we start naming the cycloalkenes. when you're doing cycloalkenes, you want to keep the double bond on the lowest number possible, but also you want your substituents, your children, to be on the lowest number as well. And it's very important for you to know that the location of the double bond doesn't need to be stated when you write it out. It doesn't need to be in the name. For instance, we have a methyl group right there. We will say that when we're naming it, we will say 1, 2, 3, 4, 5, and 6. Or let's see, 1, 2, 3, 4, 5, 6. Well, that's weird. 1, 2, 3, 4, 5. Yeah, that's weird. Sorry, I forgot I had a 1 there. So that is 5. And we are going to say that this is going to be a 1 methyl, because we have a methyl group on the first carbon. And instead of saying like 1-ene, we actually are just going to say cyclopentene. If you were to look at this, if you were to be given this name on an exam and asked to write out this shape, you would realize that this is a pentene. A pentene, so we have 5 carbons. One of them is double bonded. And there's a cyclo fashion, so we actually have to write out the pentagon. And there is a methyl group on the first carbon. Okay. And obviously you're not going to put the double bond right there, because the well, I mean you could, but then the methyl group has to be over here and not here. Do you understand? So for cycloalkanes, the location for the double bond doesn't need to be stated in the name. You have to have the double bond on the lowest number as well as the substituent. So both the substituent and the double bond need to be found on the lowest number. In this case, both of them are going to be found on carbon number 1. We will begin numbering by prioritization. So double bonds are pretty important. They're more important than single bonds. So a double bond is more important than this one. So we are not going to number going this way. That's bad. We're going to number starting at the most important portion. So we are going to say 1, 2, 3, 4, and 5. It doesn't matter if you went the other way. It doesn't matter if you did 2, 3, 4, 5, or 6, because, well, as long as you have the double bond as number 1, then it's practically the same thing. So I'm right-handed, so I go on the clockwise. It's just important for you to have this double bond as the first number, right? So the lowest number for your double bond. It's good. So we have a methyl group on 3, 4, and 5, so we will say 3, 4, 5, trimethyl, cyclohexene. Hexene with an E. So 3, 4, 5 cyclohexene. And realize that the double bond has to be a higher prioritization. It has to be more important. So we put that at the first number. So we number it first. And then we go down the line and number the rest of the substituents. What if you have an alcohol attached to a molecule that has a double bond? Well, alcohol, again, is going to be super important. Alcohol is really important to a lot of people. And so we're going to give it the lowest number as possible. So I'm not going to number from left to right. Instead, I'm going to number it from right to left. 1, 2, 3, 4, 5. I do this because alcohol is super important. That is priority number 1. So let's see our substituents. We have a methyl on the 4, so that's 4-methyl. Do I have anything else? There's a double bond on the 3rd carbon, and we will say that this is a 4-methyl 3-pentene, and instead of saying pentene, we will say that this is a 2 all. So let's kind of digest what I just wrote. There is a methyl group on the 4th carbon. Pentene means that this is a double bond, and it's a pentane, so I'm expecting 5 carbons. But on the 3rd carbon, there's going to be a double bond. That's what pentene, 3-pentene means. On the 2nd carbon is going to be an alcohol. It's going to be an alcohol group. We can also write this as 4-methyl pent 3-ene 2 all. So what changed? This number 3 kind of smudged its way between pent and ene, so it's all just about shifting. So 4-methyl 3-pentene 2 all can also be written as 4-methyl pent 3-ene 2 all. Not as nice to say, it's not as elegant, but sometimes it gets thrown at you. Very ugly. I don't recommend it, but it happens sometimes, right? It happens. For this one, we're going to start numbering at alcohol, but I'm not going to do this. No. Instead, I'm going to number this at number 2. So we always want our substituents to be on the lowest carbon. If I went to the left, then this would be a 6 right here. Yeah, this would be a 6, and that's not good. We always want the lowest number. So I'm going to have the alcohol on the 1st carbon and the methyl on the 2nd carbon. This becomes a 2-methyl 2-cyclo, because it's a cyclical, it's like a shape. Cyclohexene 1 all. So let's digest. Cyclohexene means that this is a cyclical molecule. Hexene means that it is a 6-carbon ring with a double bond on the 2nd carbon. And there is also a methyl group on the 2nd carbon. On the 1st carbon, there's going to be an alcohol. This can also be written as 2-methyl cyclohex 2-ene 1 all. This number 2 gets shifted between the hex and the ene, and the cyclohex kind of combines with the methyl group. So again, we always keep alcohol as priority number 1. We keep our substituents on the 2nd lowest carbon number. In this case, methyl would much rather be on the 2nd carbon, and it would hate to be on the 6th carbon. It hates it. So don't do that. Keep everything on the lowest number possible. 2 common groups that you'll see in organic chemistry are the vinyl groups. That's a vinyl. This is an allyl or allyl, something. So a vinyl group is often referred to as an ethanyl, E-T-H-E-N-Y-L. And this is kind of complicated, but it's called a prop 2-ene 1-yl. So not intuitive, just go by vinyl or allyl. The difference between a vinyl and an allyl, that there is 1, 2, 3 carbons in a vinyl, and there is 1, 2, 3, and let's see what else. Actually, this does not count. So it's 1, 2, and then this carbon is being connected to the parent group, so there are only 2. There are only 2 carbons and an ethylyl, or vinyl group. However, here there's going to be 3 carbons. That's where you get your propyl for, right? You get your propyl by having 3 carbons. Vinyls have 2 carbons, allyls have 3 carbons. And, of course, both of them have double bonds. So here are the special groups in action. The main thing you want to do, as always, just write out your carbons. It's 1, 2. This does not count. That is a bromine connection. So there are only 2 carbons in here. And it's a double bond. So you can say that this is a vinyl bromide. Or you can also say that this is a bromoethene. Over here, this is 1, 2 carbons. This is not going to count. So that is a vinyl. And we have a shape. That's a triangle shape. We will say that this is a cyclo, and 3 carbons, 1, 2, and 3 on the triangle, propane. You can also say ethynyl cyclopropane. Because, again, this is a ethynyl group right there, and it's connected to a cyclopropane, so it's very intuitive. Ethynyl cyclopropane. For the other one, we're going to write this in blue so you don't get confused. This is 1, 2, 3. Not 2, it's 3. And the only one that I know that has 3 bonds by itself, and it's double bonded, or not 3 bonds, but 3 carbons, and it's double bonded, is called an allyl chloride. Right? If we had a bromine, it would be allyl bromide, allyl fluoride, allyl iodide. Or you can actually call it a 3-chloro. Notice that I gave precedence, I gave importance to this bond. So 2, 3, 3-chloropropane. Because propane is only for 3 carbons. This is 3 carbons right there. Or not propane, but rather propene. So 3-chloropropene, you have 3 carbons, that's a propene, with a double bond, that's the ene. And your chlorine is attached to the 3rd carbon. So 3-chloropropene, or for the common name, that's allyl chloride. For this molecule, we start numbering at the alcohol. It has more importance. That's 1, 2, 3, 4, 5, 6. So that's a hexanol. That's a hexanol. And on the 3rd one, you have a 1, 2, and 3 carbons with a double bond, so that's an allyl. So we will say that this is a 3-allyl hexanol. If you really want to get into IUPAC specific naming, you can say 3-prop to ene all, or not il, but not all, but rather 1-il, prop 2 and 1-il. Very disgusting. Not really good. I don't favor it at all. Cyclo, hexan, or hexan. Wait, 1-all. It's very complicated if you do it like that. It might show up on the exam. If anything, for this kind of study tip, I would just vaguely remember that prop 2 and 1-il is for an allyl, because allyl has the YL. The propan would have to be 3 carbons. It has an N, so it's double bonded. So there are the propane. So the propane is going to be 3. It's an en for the double bond, and the YL can come from the allyl. So I guess that's one way you could remember it. You can memorize it, right? Prop 2 en 1-il for an allyl, and then cyclohexane 1-all if you really want to get super specific. I don't recommend it. I actually like doing the first one better, but that's just me. So now we begin with cis and trans double bonds. This is going to be classified as cis. Notice that this chlorine relative to this carbon is up, and this chlorine relative to this carbon is also up. When 2 substituents are in the same direction, for instance, these chlorines are both facing upwards, they're classified as cis, because cis means the same, and they are in the same direction. And we will classify this as a cis dash 1, 2, because that's 1, 2, cis 1, 2, dichloroethene. So this ethane molecule has a double bond, so it becomes ethene. There are two chlorines, dichloro. Those chlorines are on the 1 and 2 carbons, the first and second carbons, and they are both facing on the same direction. So it is a cis 1,2 dichloroethene. Notice for the second molecule, chlorine is facing upwards and the other chlorine is facing downwards. So they are in opposite directions. Whenever we have opposite directions, we can say that this is a trans. And after that, it's just the same thing. So trans, 1,2 dichloroethene. Trans just means that they are in different directions. This chlorine traveled downwards. They are completely different. On a double bond, you cannot rotate. You actually have to take off that chlorine and put it downwards. So it's a completely different molecule. It has different boiling points, melting points, different properties as well, right? So yeah, cis is the same and trans is going to be the different direction. Completely different for trans. Also on an exam, if they ask you which one is polar and which one is not polar, this one is going to be polar. We have a dipole moment going upwards right here. So these dipole moments do not cancel out. So we have different properties. This one is more polar, it has a higher boiling point. This one is actually non-polar because these molecules, they cancel out their dipole moments. They're completely across from each other and they're in different directions, so these cancel out. And so that would be non-polar. And it probably has lower boiling points and lower melting points compared to this one. So there you go. Cis usually has polar properties and trans usually is not. It's usually non-polar, I should say. We begin numbering by starting at the alcohol. 1. If I go upwards, that's 2, 3, and 4. What if I go downwards? You should be doing this on the exam. What if I go downwards? That's 2 and 3. So I'd rather have a 3, what is this, 1, 2, a 3 ethene, and I would not want, well, sorry, let me rephrase this. I would rather want a 3 ethene and not a 4 ethene. 3 ethene is the lowest number, so I'd rather want that. So this is an ethene, 3 ethene, and this is a double bond right there. Sorry. We will merge these components together. We will say that this is a 3 ethene, or I should say ethenyl, and this is a 2 cyclopentane. And where's my alcohol? Well, it's on the first carbon. So we say 1-O. So let's digest it. Pentene means that there is a molecule with 5 carbons, but one of them is double bonded. That's where the ene comes from. There's an alcohol group as well, this OL, and it's going to be on the first carbon. The double bond ene is going to occur at the second carbon. And there is a ethenyl. That means that there's an ethane group attached to the third carbon, but that ethane group has a double bond. So it is 3 ethenyl, 2 cyclopentane, 1-ol. And they are very hard to pronunciate, or to pronounce, and I'm sorry, right? I stutter a lot, but it is a 3 ethenyl, or right, 3 ethenyl, 2 cyclopentane, 1-ol. And I'm actually forgetting an O, cyclo. So, there you have it. For this molecule, let's begin counting. That is a, well, I noticed that I only have methyl, ethyl, and a double bond. Double bond is super important when it's compared to just basic alkanes. So we will begin counting from left to right. 1, 2, 3, 4, 5, and 6. So I know for sure that this is a hexene. It would be a hexane, except we have a double bond. If it's a hexene, where is that double bond occurring? Well, it's occurring at bond number 1, so we will have a 1-hexene. And what's left to do is to figure out what is going to be on the substituents. What substituents are there? Well, we have a 2-methyl, 2-methyl. We have a 4-ethyl. Alright, now we're ready to cook up a name. So we have, in alphabetical order, we have 4-ethyl dash 2 dash methyl dash 1 dash hexene. So separate your process first. First of all, you should be looking for the longest carbon chain. Then you're going to assign importance, because importance means where we're going to count first. So the double bond is more important than everything else in this molecule. If they're an alcohol, I would rather count from the alcohol and then the double bond. However, there's only a double bond here, so I count from the double bond. After that, you name your substituents, you number them, you separate them, and then you bring them back together into a full name. So 2-methyl is not alphabetical. You're going to have 4-methyl, or 4-ethyl, 2-methyl, 1-hexene. Right? So E before M, and then your double bond occurs at 1. There are 6 carbons. Methyl occurs at number 2. Ethyl occurs at number 4. Everything is in tip-top shape. Can you make a molecule from the name? Well, I want you to make a molecule from the name that I just gave you. So let's begin. We have a pentene. Well, that means I have 5 carbons and I have a double bond. So I don't see any cyclo in it. That means that I'm not going to do a shape. I'm just going to be doing lines. Right? So 1, 2, 3, 4, 5. The double bond occurs at carbon 2. We will say it is over here. Right? It is over here. And then we have dimethyl. So I know I have 2 methyl groups in this molecule. Where are they? Oh, they're on 2 and 4. Okay, so 1, 2. We have a methyl group. 3, 4. Another methyl group. And that would be a 2,4-dimethyl-2-pentene. Again, we have a pentene, and there is no cyclo. So we say 1, 2, 3, 4, 5. The double bond occurs at bond number 1, or carbon number 1, so we'll say it's right there. And there are 2 bromo atoms right here. And they occur at carbon 4 and 5. 1, 2, 3, and 4. So you're going to say bromo right there. And 5 occurs 1, 2, 3, 4, 5, 6. Actually, yeah, I always mess up on my carbons. So this is a hexene. Whoop. Right? And this bromine occurs right here. So let's see, 1, 2, 3, 4, 5. There are 5 carbons, and the double bond occurs at carbon number 1. There are 2 bromine atoms, and they occur at carbon number 4 and 5. So 1, 2, 3, 4, and 5. And that looks pretty correct to me. Notice that there's a cyclo in here, so I'm going to be drawing a shape that's closed, and it's a pentene. So I want to draw a pentagon. 1, 2, 3. Right there. 1, 2, 3, 4, 5. That's a pentagon. And, well, there's a double bond somewhere, and let's just say it's over here. Because location doesn't need to be stated when you're doing these type of problems, especially for cyclopentene. You don't need to say the location for the double bond, right? But it's kind of subtle. It's kind of subtle. If you were to do 1, 2, 3, and 4, 5, that must mean that there is a methyl group on the 3rd carbon, so methyl group, and there's a methyl group on the 4th carbon, right? It doesn't matter if you go 1, 2, 3, and 4, it's still going to be the same thing, you see? So that's why the double bond is not stated in the location, because if you were to do 2, 3, 4, 5, it's going to be the same molecule. It really is. So that's why the location is not stated for this type of problem. Finally, we have 1,2-dichlorocyclohexane. Hexene. If it's a hexene, it's going to be hexane based. Right. And let's see here. There is a hexene, so that's a double bond somewhere. Let's just say it's over here. and we have 2 chlorines. One occurs at carbon number 1, and one occurs at carbon number 2. So that's a chlorine, and that's a chlorine. Let's see. Is this legal? 1, 2, 3, 4. Carbon has 4 bonds. 1, 2, 3, 4. Carbon has 4 bonds. Perfectly legal for you to do. And let's see here. That is a 1, 2, 3, 4, 5, 6. That's a hexane. There's a double bond, so it becomes hexene. Dichloro means that there are 2 chlorine atoms, and they occur at carbon number 1 and carbon number 2, which is what we have here. That's 1, 2, 3, 4, 5, and 6. Hopefully, you can now do these types of problems. If they're giving you the name, you can draw it out. If they give you the figure, you can name them. And I hope that you found this video very helpful. And I hope that you continue studying and that you don't hate organic chemistry that much. Again, have a great day and thank you for watching.